Ever wondered how AI paints a sunset or composes a melody from nothing? It all starts with a clever trick called diffusion models, but here's the twist. Scientists just cracked a code to make them way faster. Let's break down this breakthrough and see how it's rewriting the rules of AI creativity. Diffusion models are like digital alchemists. They take random noise and slowly turn it into something meaningful, like a photo or a song. But here's the hitch. Traditional methods are slow. Think of them as solving a puzzle by randomly moving pieces for hours. They need hundreds of steps to get it right, and each step is like a tiny guess in the dark. Why is that a problem? Imagine generating an image requiring your computer to take 100 tiny steps to figure it out. It'd be like using a calculator to add two numbers, super accurate but super slow. That's where proximal diffusion models, ProxDM, come in. They're the AI equivalent of switching from a bicycle to a rocket ship. ProxDM swaps out the old guessing game for something smarter, proximal operators. Think of these as a compass that points directly to the lowest energy point in the data, like finding the nearest tree in a foggy forest without wandering aimlessly. Instead of calculating every possible path, the model uses this shortcut to zoom straight to the answer. Here's where it gets really cool. Traditional methods use forward discretization, like taking small, predictable steps. But ProxDM flips the script with backward discretization. It's like planning a road trip with GPS instead of fumbling with a map. The model solves an equation that considers the whole journey at once, making each step way more efficient. And the results? ProxDM achieves the same quality as old methods, but in half the steps. On datasets like handwritten digits or real-world images, it's generating sharper, more accurate outputs faster than ever. It's not just a tweak, it's a fundamental shift in how AI learns to create. Why does this matter? Diffusion models power everything from AI art tools to drug discovery. By making them faster, ProxDM could unlock real-time creativity, handle massive datasets, and even make AI more accessible for everyday users. It's like giving AI a superpower, the ability to create without the weight. So what's next? This isn't just about speed, it's about rethinking how AI interacts with data. By replacing old math with smarter tools, researchers are paving the way for more robust, scalable systems. And as always, the journey doesn't end here. New questions arise. Can this work for video? Let's zoom in on the math. Traditional diffusion models rely on gradient flows, continuous processes that mimic physical systems. But translating these into algorithms requires discretization, breaking smooth processes into steps. The classic approach, forward discretization, is like taking cautious steps downhill. But ProxDM uses backward discretization, which looks ahead to balance stability and progress. This is where proximal operators shine. They act like a hybrid of gradient descent and constraint enforcement, ensuring the model doesn't overshoot or get stuck in local minima. Think of it as a self-correcting mechanism. Every step is both a guess and a correction. Now let's talk about Hessian matrices. These describe how a function curves in multiple dimensions. In optimization, they're crucial for understanding stability. But traditional methods require exact Hessian calculations, which are computationally heavy. ProxDM sidesteps this by using local curvature estimates, making the process faster without sacrificing accuracy. Another key player is KL divergence, a metric that measures how different two probability distributions are. In diffusion models, it's used to compare generated data with real data. ProxDM minimizes this divergence more efficiently, ensuring the output is both high quality and statistically consistent. These advancements aren't just academic, they're practical. From generating realistic images to simulating quantum systems, ProxDM's efficiency opens doors to applications we've only begun to imagine. The next time you see AI create art or a self-driving car navigate a street, remember, behind the scenes, math like this is ensuring it works as intended. So what's the takeaway? Diffusion models are no longer just slow experiments, they're becoming the backbone of AI innovation. And with breakthroughs like ProxDM, the future of machine creativity is brighter, faster, and more powerful than ever. Stay curious and keep exploring the math that shapes our world.